In the last video, we derived the quantization equation for energy using the Bohr model and also using my model. For the Bohr model, we used the Bohr momentum equation and the equation for centripetal force in the atom to derive the energy quantization equation as follows, with a corresponding orbital radius as follows. On the other hand, using my momentum equation and the equation for the centripetal force, we arrived at the following equation for energy and a corresponding radius as follows. We showed by derivation that these are the same forms of the equations for solar systems, taking note of the equivalence of Z and alpha and H and G. We also showed that my formalism directly explains the Zeeman effect like so. This approach accounts directly for the fine structure splitting observations, which is as a result of the Zeeman effect. Looking at the diagram, we see that the Bohr quantization energy equation can only give the energy of the blue light energy level, which occurs when n is equal to 4, which is n eta equal to 16 as per my model. To account for the extended orbits, we require a magnetic quantum number as per atomic physics. Take a look at my energy equation. To calculate the energy of the first orbit above the blue line, for example, we simply take n to be equal to 17 and we get it. The same thing for all the other orbits. Also notice that in the Bohr model, to get the energies of the orbit 12 or 20, we need a different quantum number called the momentum quantum number. But in my model, you simply take n equal to 12 or 20 respectively. So you see that in my formalism, we don't need those extra quantum numbers, and also the mathematical formalism of the Zeeman effect to explain the emission and absorption spectra, as well as many other things as we shall be finding out. The electronic transition between any two of these levels is what results in the fine structure observation, and the corresponding energies can be calculated by taking the energy difference of the two levels and using my energy equation, which is an easier thing to do than use the complex Zeeman formalism. We have seen using our equivalence principle of atoms and solar systems that the energy of a planet is also quantized and given by the following equation. We can simplify it to this form, like we did for the atom, such that E0 is equal to this. This equation treats all planets as being identical and having the same average mass, little m. However, in the case where the masses of the individual planets are known, you can use this relation for G to modify the energy equation. Putting this relationship in the energy equation yields the following red expression, which can be modified to this. We now have m in the simplified equation because m is now a variable like alpha and n. E0 becomes slightly modified and is given by the following green expression. We can only think this way because planets are really big relative to us, and we can measure their masses accurately, especially for planets close to or in our solar system. We cannot think like that for atoms because we cannot see electrons. So we do not know if truly all electrons have the same mass. I can say with confidence that they certainly don't by simply looking at their equivalents to planets. So what we have is the average mass and charge for electrons. The idea of average mass should also be implemented in the analysis of solar systems because there are of course some of them that are so far away that we can't see, just like atoms. Nevertheless, I am showing this alternative, which is a more precise approach, just to convince you more on the validity of the model. For independent masses, this is the energy equation and the corresponding E0. As you saw in the previous videos, G prime is 5.8 exponential 15 and G is 1.72 exponential 42. Let's take an average mass in the neighborhood of 2, bounded by an error value of 0.3 exponential 26 kilograms. Subbing in the numerical values of the constants of the green equation, we have 2 pi squared times 4.45 exponential minus 21, which is the square of the universal gravitational constant G, times 6.25 exponential 58, the square of the fundamental mass of a star, which we derived in the first video of the series, or divided by the square of G prime, which is 3.36 exponential 31. This gives us 1.63 exponential 8 joules for the fundamental energy. The values of the E0 in the other expression is the same, just with the addition of the cube of the average planetary mass, which is 8 exponential 78. And also, G prime has been replaced with G. This gives approximately 1.48 exponential 34. I said approximately because I have not taken into consideration the 0.3 error value of the mass. There is a more simplified way of writing the classical equation of energy. Recall that the velocity of a rotating body is given by 2 pi r on t, and the period t is given as follows. When we sub in v in this equation, we have the following. Now, subbing in t squared produces the following yellow expression. When you simplify the bracket, you get the following purple expression. Half of gmm on r minus gmm on r gives minus half gmm on r. So you see that the total mechanical energy of an orbiting electron or planet is minus half its potential energy. We have below the 8 planets of our solar system, their respective mass and quantum numbers as shown. We are going to calculate independently their energies using the 3 different expressions for energy and place them under each of these respective columns. So we have first the classical expression, next is the quantization expression with independent masses, and lastly, the quantization equation with average mass of the planets. The respective E0s are given above. I have ignored the minus signs just for simplicity purposes. Under the first column, we have the following values for energy. These are the values you will find online or in textbooks. Under the next column, we have the following values. You see that because we are using precise masses, we have essentially the same results. The values of energy for the third column are as follows. These values individually seem a lot shifted, but a collection of all the values produces an interesting result. Let us look at the total for these columns. Do you see how they almost are the same? Meaning that even if we did not know much about the solar system, we could still be able to estimate its total energy accurately. By this, we can analyze solar systems throughout the universe, even ones that we can barely see, even with aided eyes. Modeling the cosmos in this way may provide a greater insight about the universe and make it easier to study and understand, because we can model it as an atom and do experiments of the universe in a small scale. We shall continue with the development of the explanation of the nature and sources of gravitational waves using this model, just like EM waves are studied using atoms. So please subscribe to follow. Thank you, and see you next time on the Classical Universe.